The focus of this video lesson is Intro to Floor Plans. Example 1. Jerry is using the floor plans for his new home to help him purchase base molding for the place where the walls meet the floor. The plans are drawn using a scale in which a 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler, and he finds that they total 23.5 inches. If the molding costs $2.10 per foot, how much will Jerry spend on molding? The first thing we need to do is let's come up with a sketch that shows what we're looking at. So we know that Jerry is looking at plans, and we're going to say that this is the room he's looking at, and we're going to just pretend for the sake of this that it's rectangular. Now, the wall he's looking at, we know on the plan when he measured with a ruler, it was 23.5 inches. Now, we know in real life, the actual wall is much larger, right? So our real or actual wall is much larger. We don't know how large, so let's call it X. Okay, so this wall here is 23.5 inches on the plan, and in real life, it's X feet long. Now, we do know the relationship between the plans and real life. We know that every 1/4 inch in the plan is actually 1 foot. So we know that for the plan, if we have a 1/4 inch or 0.25, that on the plan, that translates to 1 foot. So what we're going to do is we're going to create a proportion that compares the plan to the real life. Okay, so we know that in our plans, we know that the wall is 23.5. And we know that every single one of those 1/4 inches is representing an actual foot of space in the real house. So we know that the 23.5 in real life is X in length, and we know that the 0.25 in real life is 1. So what you're going to notice here is on the left side, we have the plan, we have the wall over the scale. So plan, the wall over the scale, and then on the other side, we have our real, and we have the wall length, and then we have the scale. So you'll notice that we have the plan on the left and the real wall on the right, and for both of these, we have wall over scale, wall over scale. And it's important that they match that way. It's important that the reals are together, the plan is together, and that the wall is in the numerator or top of the fraction for both, and the scale is in the denominator or the bottom of the fraction for both. So now what we're going to do is, if you look on the right-hand side, we have X divided by 1, which is just X. And then on the left-hand side, we have 23.5 divided by 0.25. So let's use our calculator. 23.5 divided by 0.25. We get 94. Now remember, this is in feet because the real one is in feet. So 94 feet. Okay, so we know then that the actual wall is 94 feet in length. Now, we want to answer the question. So the actual question being asked here is, if the molding costs $2.10 per foot, how much will Jerry spend? Well, we can see here that he needs 94 feet of molding. Okay, so we're going to put our cost at $2.10 times the 94 feet that he needs. Okay, let's use our calculator again. And we get $2.10 times the 94 feet of molding, and that's $197.40. So we will then say Jerry will spend $197.40 on molding. And that's it. Now it's your turn to try. Try this. The length of a room is 17 feet. When using a 1/4 inch to 1 foot scale, what is the length of the room on a floor plan? Example 2. Gabriella plans to carpet her living room, except for the 1/4 circle shown in the corner. That area will be wood floor where she will put her piano. The radius of the 1/4 circle is 8 feet. If carpeting costs $9.55 per square foot, what is the cost of the carpeting that she will use in her living room? All right, so let's take a look at what information they're giving us. So we know that Gabriella wants to put carpet in her living room everywhere except for this 1/4 circle that's removed. So we also know that the radius of that 1/4 circle, it says, is 8 feet. That means the length from here to here is 8 feet. And also the length from here to here is 8 feet. Now we do need to remember what the area of a circle is, and then we only need 1/4 of it. So if we think back, we know that the area of a circle is equal to pi r squared. Okay, but we don't want a whole circle, we want a 1/4 circle. So the area of just a 1/4 circle is going to be pi r squared divided by 4. So 1/4 or 1/4 of the circle. So let's take our radius, our 8 feet, and we have pi times 8 squared divided by 4. 8 squared, 8 times 8 is 64. So we have 64 pi divided by 4. Then we have 64 divided by 4, which is 16. So we have 16 pi. Now at this point, we're going to approximate what this is. We know that pi is approximately 3.14. So this is about 16 times 3.14. Now, of course, if your calculator has a pi button like this one does, you can use that. It'll be more precise. So let's do that just for the sake of precision. So we see then that the area of our semicircle is about, let's say, 50.3 square feet. All right, so that is our area in here. Now, ultimately, she wants to carpet this space in here. So let's figure out the area of the larger room and then subtract the 1/4 circle. So we know to get the area of a rectangle, it's just length times width. So the length of the room is 25 and the width is 16. So we have 25 times 16, which is an area of 400 square feet. So what we're going to do then is we're going to take the area of our rectangle and remove the area of the semicircle. So the carpeted area, so the area to carpet will be 400 minus 50.3, or 349.7 square feet. And obviously at this point, she will likely order 350 square feet, right? Because you're not going to order a fraction of a square foot. And then the question is, how much will she pay? So the carpeting costs $9.55 per square foot. So our cost will be the $9.55 times the 350 square feet that she needs of carpet. So we have $9.55 per square foot for 350 square feet. That's going to be $3,342.50. So $3,342.50 for carpet. So Gabriella will spend $3,342.50 on carpet. And that's it. Now it's your turn to try. Try this too. Express the area of the shaded region in the room shown algebraically. Now, just a quick reminder, when multiplying variables, let me show you an example. So if I had the expression 3x times 2x plus 4, 3x times 2x, 3 times 2 is 6, x times x is x squared. 3x times 4, 3 times 4 is 12x. And remember, you can't combine like terms because these are not like. Remember, for them to combine, they have to have the same variable and the same power. So at that point, we leave our expression just like that. Give this a try. Send me your answer before you submit it to get feedback.